All right, welcome to the CalGIS Webinar number 5. For those of you who haven't joined us before, we're doing a series of webinars leading up to the 20th Annual CalGIS Conference, which will be taking place in 3 months. It'll be taking place April 14th through 16th in Monterey, California. If you haven't had a chance to see any information about that, please follow us on Twitter at the hashtag CalGIS, or go to calgis.org, and that's a location where you can go out there and you can register for the conference, you can see information about the conference, get information on your hotels. Any of that kind of stuff is available at calgis.org. You're welcome to contact us. Down at the bottom is an email address, calgisconference@gmail.com, and you're welcome to anytime send an email in there. We check it every day, and so if you have any questions about the conference, any issues or problems, please hang on a second.
The broadcast is now starting. All attendees are in listen-only mode.
Okay, I guess something was wrong with the GoToWebinar, so I have to start all this again. Thank you for being here at the CalGIS webinar. For those of you who haven't had a chance to participate with us before, the CalGIS webinar is a series of webinars we're going to be doing leading up to the 20th Annual CalGIS Conference. This conference will be taking place April 14th through 16th in Monterey, California. And you can see information on the screen right now about how to contact us and how to follow information, particularly the website, calgis.org, and you can follow us on Twitter. We have a few of our team for the program and the planning of the conference, send some information out about the conference periodically. Today's schedule, I'm going to go over the information on CalGIS, what's changed, what's updated over the course of the last month since we last met, and then after that we will be, let's see, well, we'll see. Can anybody hear me? Somebody send me a little note about, oh, okay, there's Christina told me yes. Wanted to make sure. Okay, so I'm going to give a little bit update on the conference, then we'll have Alex Barth from Mapbox speak to us, and then we'll have Landon Blake. He's still working on a little technology glitch right now, so he's going to go at about 11:35, as long as we can make the technology work for us. So with that, let me start on telling you a little bit about the conference. First of all, there's not a lot of information right here, but I wanted to let you know that Sunday evening there's going to be a developer meetup the Sunday evening before the conference. So we'd hope for those of you who can, you can join us, come that Sunday. Participate in the developer meetup. Bring a laptop. We'll put some more information out on the conference website as we get a little bit closer to that to the conference, and so you'll have a chance to have a chance to see what's going on in that developer meetup. The next day, Monday, is our workshop day. What we have planned right now is the Marine GIS workshop, and we've talked about that before. That's getting put together right now. It looks like it's going to be a great workshop. There's going to be the Esri ArcGIS Online Story Map Workshop. So we would like you to bring your laptops if you register for that one. Come participate a whole day talking about story maps, building them, and then we'll have a bit of a competition with some prizes awarded for those of you who come out and show up with, put together a great story map. Then the third workshop is going to be kind of a little different. It's going to be an open source workshop, but it's going to have 2 parts. In the morning, there'll be a combined morning session where people from Boundless and Mapbox will be going over parts of their information that they have on open source and things around that. We'll then break for lunch, and after lunch we'll have 2 rooms so that each of them can have a bit of a chance to do a deeper dive with those people who are the most interested in that piece of the workshop. That afternoon, we'll also have meetings of the State GIS User Group, the CGIA Board, ERISA chapters, and we're trying to do something, trying to set this up right now, so it's still a little bit up in the air, but we think we're going to be able to do a set of people who will be there if you have an interest to bring your resume and maybe do some practice interviewing with somebody in the field. If you had a hard time, trying to get a job or landing a job and you'd like a little bit of advice, we'll have a few people trying to sit down one-on-one with people and go over that information. And then that night, we're going to have a dinner at the Cannery Row Brewing Company. It looks like it's going to be a great event. Tuesday, our schedule is going to look somewhat like this. This is still open for small changes, but we're going to open the session with the opening information about the conference, followed by our morning keynote address from Mike Magursky with Code for America. We'll have a break to have a chance to see the exhibitors a little bit, and then we'll have a second keynote, Eric Gunderson from Mapbox, and he's going to be talking. He has a presentation he's going to be doing for us. After he's done, and we have some time for questions, we'll then go on to a town hall discussion. The plan right now is a discussion about the future of GIS and geospatial technologies, kind of where things are going, and have a chance for everybody to get involved in that conversation, and perhaps express to people who are in the room some concerns or things that they'd like to see happen. We'll have a lunch that day, and then after that, we'll have another keynote. We'll all be in one room for the day. That keynote is Dylan Lorimer from Google, and he's been involved in much of Google's geospatial development work over the course of the last number of years. We'll have a break in the afternoon, then there'll be a panel discussion, education and career development, and then we'll have some lightning talks before we go into the exhibitor networking reception. After that, there'll be a beach party activity. It's kind of a come and go thing. That's not you have to be there at a certain time. We'll have more information about that as we go on, but we're doing it at a place where they have an indoor area and they have the beach. So if the weather is inclement, we can still have this activity. We assume that a number of you will want to go out and have dinner and those kinds of things, but this will have a chance for you to get together and have a fun evening. On Wednesday, there's going to be the gold sponsor session and breakout sessions all morning. Lunch, afternoon breakouts, and then our closing keynote will be starting at about 2:30. It'll be Jack Dangerman from Esri, and he's going to be coming to our conference. He came at the 10th conference, and he'll come here at the 20th and participate and talk to us a little bit as we close the conference, then we'll wrap that up. So with that, if any of you have any questions about the conference, please send some, ask questions on the box there at the bottom of your GoToWebinar screen. With that, what we're going to do now is we'll switch over to Alex Barth. Let me bring him in and turn on his webcam. Oops. Alex, you there? Okay, there he is. Alex is with Mapbox, and Alex is going to be participating in the conference, I believe, also helping us do our workshop on Monday, and he may even do another presentation on Wednesday for you. So if you have any interest in learning about Mapbox, there's going to be a great opportunity at this conference. So what we did today, I asked Alex if he would participate with us to kind of introduce Mapbox to us, and he's going to do about 15 minutes or so and then give some time for questions. So if you have questions about Mapbox as he's going through, type them in the box and we'll ask them at the end. Okay? With that, let me change you to be the presenter, Alex. And there you go. Let's see if your screen pops up.
Fantastic.
Let's see.
Can you see my web?
I can't. Hang on just a moment. We'll see if it shows up here. Let's see. Can you... I'm not seeing your screen at the moment.
It does say I'm sharing the screen. So
Okay.
I'm sharing this on air.
All right.
On air, and you should be seeing
Oh, there we go.
the Mapbox website.
There we go.
You got it?
All right. So what I'm going to do is I'm going to back out of here and turn off my camera. So if any questions come up, I'll let you know.
Fantastic. Yeah, so hello everybody. As Jeff just said, I'm Alex from Mapbox, and I'm looking forward to give you a quick introduction to Mapbox here in the next 15 minutes, and then open this to questions. This is going to be a little bit of a head start on the conference that's going to come, and really designed to give you a quick overview of what Mapbox is about, what tools we provide, and who's using it, right? So as you follow along, I'm going to step through a couple of tools really quick here. If you'd like to get more information about it, always hit up mapbox.com. But really, feel free to ask questions here, not only on the webinar, but also on Twitter, as you think more about the presentation, or just get directly in touch with me on alex@mapbox.com with any questions you might have as a follow-up. Good. This is mapbox.com. At Mapbox, we create tools for developers and designers to create great maps for the web or mobile. We're really all about putting great tools in people's hands for publishing geo information. You can think about us a little bit like a Lego box for maps. We offer a variety of, not only a variety of open source tools for creating your own maps from scratch, but we have base maps, like global vector-based maps that you can use out of the box. We have satellite maps that you can use directly from Mapbox, and this is exactly what I'd like to show you. Before I jump into like actual tools, I want to show a little bit who is using Mapbox. I'm just going to use our website here to give you a couple of examples. Because they illustrate really nicely of what you can do with our tools. First example here would be Foursquare, the social media location sharing tools. They are using Mapbox as a base map. You can see here this base map is created by Mapbox to present their point of interest information here. On top of the base map, you would be like the DC9 rooftop bar as an example. Another example would be Pinterest. They're using a Mapbox map as a base map for these pin boards that people use to collect interesting or to collect stuff that they're interested in from all over the web. Again, we are powering here this base map, and you see this base map looks very different than the one that we have here in place for Foursquare, and that just illustrates like the design capabilities of Mapbox, really the control of design that you get over this base map, while maintaining speed and global availability of data. This is a global base map down to zoom level 19. Designed to the exact specifications here of Pinterest. And you see how San Francisco label here is using actually a font that was specifically created for Pinterest, things like that. Mozilla would be another example here. They're using Mapbox maps for their locator maps on their website. Another example would be Le Monde. They launched Mapbox maps with French labels just almost a year ago now for data visualizations and news browsing. Evernote is using Mapbox. Financial Times is using Mapbox a little bit like in Le Monde for data visualization. You see a little interactive that they created about the ethnic breakdowns here in the Middle East. USA Today uses Mapbox across the board for weather maps and all kinds of locator maps, but they also used Mapbox for the elections, for the last presidential elections. Then there are further examples with Hipmunk, National Park Service is using Mapbox maps, and then there's fun apps like Map of the Dead on mobile that are using Mapbox maps. So this is all like just examples of how some of the higher profile clients are using Mapbox maps. And again, really, what's interesting about what we're offering here is we have a couple of great maps for you to start really fast out the gates, but we also have the tools that allow you to create your own data overlays or your own designs. And publish them on the web, either for data visualizations or really just as a backdrop, as a base map for information that you'd like to show on top of the map. And we're going to walk through a couple of tools here later, so that you can get a very concrete idea of what's possible with Mapbox. Now, the way how most people use Mapbox is to simply sign up on Mapbox.com, and they create an account, and they start to put together a map within a couple of minutes. And I'd like to show you that, right? So if you sign up here at Mapbox.com, you would just pick like a username and a password, and you would go. I'm going to sign into my account, my existing account here. So landing that account, you can see all the maps that I've created so far here in my projects tab. And now what I'd like to show you is how to create like your first map, your first project on Mapbox.com. So you would just click here on Create Project. You would create a base map here in San Francisco, and you could pick what kind of base map you'd like to use. This would be like our global vector map down to zoom level 19 or more, as you can see. We're using OpenStreetMap data here. I can talk a little bit about that later, but this is all we need to know for now. And I could now decide to use not only like a streets map, but I could say, okay, I'd actually like to use a satellite map, right? Let's use a satellite map, right? We're using digital globe data here. You get like a global satellite base map here, right out the gates. And now let's say I'd like to actually annotate the map and show some information on top of it. I'm thinking I'm just going to outline here a couple of things. I'm going to go into the data tab here, and I'm going to just make a quick line here of like, let's say I'd like to share with people with like my favorite like runners, something like that, right? This is like somebody's visiting. Let's say somebody's visiting San Francisco, and I'm trying to show them. It's like, look, here's a great place where you can go for a run here. You should run to the Golden Gate Park. It's beautiful. It's not very accurate, but you get the point here. I've just created a line here. Let's style this line a little bit. I'm going to make this a little bit wider. I'm going to make it a little bit transparent, right? And save this here. And yes, I already have a line here. I'm going to give this a name here, suggested run, right? And now save this, and now let me actually like stylize like the base layer a little bit here.
Hey Alex, this is Jeff.
Yeah.
There is a little bit of a lag on the screen as we're seeing it here. So
Okay.
So the less you move around the base map underneath it, probably the better, as far as how it shows.
Good to know.
Okay.
Fantastic. All right. Cool. As an example here, I'm going to switch this back to the streets layer here. This makes like the outline a little bit easier. I'm going to add here, just to illustrate like the functionality here a little bit more. I'm going to add like a marker. I'm just going to say like, oh, I live here, my home. Save that. And now, having created this map here, I'd like to share this and use this somewhere else, right? And this can be done very easily. You could just really simply like grab the map here, grab this embed link here, and just embed the map like a YouTube video. Alternatively, you could just grab this link here, which would just show the map. Let's say, yeah. Which would just show the map in the browser, right? But I do also want to show you how you can embed that as just like a YouTube video in any kind of website. Let's illustrate this here real quick by sticking this into an HTML file for a moment to give you an idea of how that would look like. Now that would be the embedded map now, right? Ready to use for you on your website with the interactivity on it. That you can imagine how you could stick this into a blog post or anything else. Now, if I wanted to have a little bit more control over the interactivity here, I could use a library called Mapbox.js. That's an open source library that we offer. It's based on Leaflet, and you can use Mapbox.js to do a little bit more with your map. I encourage you to check out the example section of Mapbox.js to give you a little bit of an idea of like what the functionality is that you can implement with it. There's geocoding that you can hook into like really easily. You can draw markers with it. You can do things like layer swipers here for comparing maps, etc. Right? But just to illustrate what's possible with Mapbox.js, right? Now, if you wanted to use your map directly in Mapbox.js and start coding with it with JavaScript, you would just grab like this ID of the map over here, and you would go and you would use like, let's just grab like one example here of Mapbox.js to work with. You would grab like just a simple map example here. I'm like copy pasting this code into my HTML file again. I'm just do a quick modification here. And then I'm just taking like the ID that I have created over here on my on mapbox.com, and I paste this here to the right spot in the code. It's very simple, very straightforward. It's a really good starting point for creating your own web applications. And now all I need to do is just call this up in the browser, and you'll see that, again, I'll have like the interactive map, including the information that are placed on it, like right directly pulled up, just in a couple of lines of code. Right, and from here you can just go and grab code from Mapbox.js, examples gallery, and just build out your application as you need it in your web application. Right. In a very similar way, if you're into like mobile programming, you could use the Mapbox iOS SDK or the Mapbox Android SDK, and also get started really quickly with a couple of very simple examples with creating a native app with Mapbox that would show exactly that information. So this is what we offer sort of on Mapbox.com, very simple, very fast ways to like create your maps here from scratch. You have some like customization options here of like the base map, and you have like really quick tools here for creating like annotation on top of the map here to get you started really quickly creating your own maps for your web applications. Now, we use the tools that we use for creating these base maps here. Those are tools that you can use yourself for creating your own creating your own maps from scratch, right? Specifically, I'd like to point you to TileMill, which is a desktop, an open source desktop map design studio. You'll find TileMill on mapbox.com/TileMill. It's software that you download to your computer and install, and that allows you to create like tile-based maps yourself. So that's interesting if you wanted to create like your own base map from scratch. Let's say you have building footprint data, or let's say you have road data from your county or from your city, and you'd like to render a map from it from scratch. It is like a tiled raster map. You can do this with TileMill, and it's very straightforward. I'm going to show you in a second how it works. What's important to know about TileMill is that it's exactly the tool that we use for making our global base map. So it's very powerful and very flexible, but we've really like taken like great care to like make the experience as simple as possible. Sort of take the pain out of creating raster-based web maps. I'm going to give you a very quick walkthrough here on how you would create like a map with TileMill. What I'm going to show you is how to create like a building footprint overlay for Washington D.C. This is TileMill as I open it for the first time. I can pause this here actually for a second and call this up again to get you an idea on how does it look like when you start this on your own computer. Go ahead to my applications. Just pick TileMill here from my applications on my computer. You can install TileMill on a Windows computer or on a Unix computer as well. Starting TileMill here. Now I'm creating a new project here on TileMill. I'm going to give this the file name DC Buildings because I'm going to show DC Buildings on it. I'm going to open this, and when I open this for the first time, you see like the typical tab screen here with the base map. You see like the world here as an example. Here we're using natural earth data. Just for this example, on the left side is a preview of the rendering. On the right side, you see like the code that influences the controls the style of this map. So for instance, if I change here the background color to red, I have like the sea of blood. Not a very pretty map. You get the idea. This is very easy to change. It's a little bit like CSS, very very straightforward to pick up, and there's actually help in line here that really helps you like each step of the way you learn part of CSS. Now, the first step here to create the DC Buildings map is to add a data layer here. I'm going to pull up like that shapefile that sits on my hard disk here from the DC Buildings directory. I've downloaded that earlier today. Just going to pick up that shapefile. I'm going to click done here. I'm going to give this an ID. The ID should be buildings. The ID is now I'm going to refer to this data later. And then I'm going to say save in style. This is going to give it now some sort of default style, so they have something to look at, right? I'm going to click here on this little loop, and this little magnifying glass is going to put like the data here onto the screen, and you see how, you know, I'm having like all the PC buildings here. They're rendering out now in green. That's sort of the default that I get. I'm going to style this just a little bit, right? So I'm going to use a blank color red so that we can see this a little bit better. I'm going to give this a line width 1 so that I have a little bit more visibility again. I'm going to give this a polygon opacity of 0 because I just don't want to have them transparent, and they can kill here the polygon fill. So this gives me a very, very simple style of the DC buildings. Now what I'm going to do is I'm going to render this layer out, and then I'm going to push this up to Mapbox hosting with a transparent background so they can overlay this over satellite imagery. And this is what I'm going to show you here in 1 second. Before I render this out, I'm going to kill the background color here so that we have a transparent background. And kill like the actual country like data layer here. I don't need the countries anymore. Just going to completely kill everything that is countries. Just have the buildings here, and you see how now this is a transparent background by seeing like this little pattern. I'm going to go here now to export and upload. Now I need to like confine like the area that I'd like to render.
Yes.
I'm going to pick like a small area here. We're just going to do a little subset here so we don't render like a very long time. I'm going to render this out here. I'm going to give this a name, PC building, and upload, right? Now this is going to render and upload directly to the Mapbox account. While this is rendering here, should be done in a second here. This should be then, right, now this is rendered out, and I can view this now. I'm going to click view. This kicks me over to my account, and on the account I can see now the PC buildings layer that are now what can I do with this? I can now just go into like into my account here, and I can now create like a very quick map. Just going to create a new project here. I'm going to go in the new project. It's giving me the base map now, right? And in here, I can now add the data layer here as an additional layer. Add layers. And I just need to find PC buildings. Okay, here we go. I select this. Okay. I can close this now. I save here. I just need to scroll over to DC, Washington, DC. There we go. Oh. As you can see, and now you can see how this overlay sits on top of like the base map that is available through Mapbox. This could be now again, this could be a satellite map, etc. But you get the idea that with sort of flexibility that the tools give, these tools give you. Now, one last thing I want to show you is a new version of TileMill that is already available on github.com and that we're about to launch here for a broader audience. You can imagine that with rendering tiles like I just showed you, that there's a certain limitation of like how large the tile sets can get, to what extent those tile sets can have, and what the number of zoom levels are that you can render, because the world is very, very large. So let's say you'd like to render a global base map. You would be talking about rendering tiles that on the order of like a terabyte or even more. And it's like not only something that is a problem in terms of like deployment, in terms of like rendering out all these tiles, but you also run into like real performance problems in just styling such a huge data set. So this is exactly what we've solved with TileMill 2, and this is what I'd like to show you here for just 1 second. I've installed Tile 2 here locally. I'm not going to go into details on how to install it. It's something that you can actually follow up here offline if you're interested. What's really cool about Tile 2 is you'll get like a sort of pre-processed data set of OpenStreetMap data that you can render, that you can style down to the street level. And now look at how fast this is. This is all of OpenStreetMap data here down to the street level. Sorry, down to the street level, available globally, right? So this is anywhere in the world. You get like the detail of OpenStreetMap here down to the street level. And this is, you can style this really fast. So for instance, if you'd like to go and change like the color of buildings, you could go in very quickly and just change like the, let me see where the buildings, let's see what was right at the bottom here. That's a good one. Building, you could just change like the value for buildings and turn them, for instance, all to green, right? This is what they would look like. Let's put the blue. Right? Now from here, you wouldn't, with Tile 2, you wouldn't need to like actually render out all those tiles and upload them to Mapbox hosting. You would just render out the style that you created here. You would just save the style that you created here and upload that to Mapbox hosting, and we would like generate like these maps on the fly for you on Mapbox.com. We going then from like having to like render out like a large chunk of the world here into tiles to just capturing like that style sheet and putting that style sheet onto Mapbox.com, giving you a lot more flexibility. This is exactly how we created some of like the more stylized maps here for Financial Times or Pinterest or Le Monde that I showed you just before. Yeah, and with that, this is actually like my quick overview here for the tools that I wanted to show you from Mapbox.com. I'd love to take questions here for another minute or two if there are any. Before we go there, I'd like to invite you all to State of the Map US in Washington, D.C. This is just like 2 days before the CalGIS conference. We're using OpenStreetMap data here in Mapbox. This is really one of like the key things that we're doing here with our global base map. We believe it's a great data set and it has a lot of potential also to be useful in the municipal or corporate sector. And State of the Map US is a really great place to like connect up with other institutions or individuals in the OpenStreetMap space. This time it's going to take place in Washington, D.C., April 12th and 13th. I encourage you to check out the website. I realize it's just right before the CalGIS conference that I'm also going to attend, which I'm really looking forward to. But if you can make the time, you're very welcome to visit the State of the Map US in Washington, D.C. With that, I'd like to open this up for questions real quick and turn this over back to Chad.
Thank you very much, Alex. I've played a little bit with Mapbox, and it's very interesting. I haven't had enough time to really get too deep into it, but if any of you have a real interest in learning about Mapbox, don't hesitate to sign up on that the Monday open source workshop, because Alex is going to be there, and he'll be talking quite a bit about the Mapbox and TileMill and some of the other aspects of what he was just touching on today. There's a couple questions here. One was, could a user customize a Mapbox map using code or script?
Code or script? Yes. So it depends a little bit what exactly you'd like to do, but there's a variety of ways of customizing Mapbox maps. One thing that's interesting to think about is how to programmatically create maps and push them into Mapbox.com from the command line. This is something that's interesting if you're, for instance, looking at a situation where you'd like to continuously render like an updated data set, maybe daily, a daily refresh that you'd like to automatically run from your server. It is possible to run TileMill from the command line and to set it up, with cronjob, for instance, on a web server, a server that's hanging on the internet, and just push from there periodically into Mapbox.
Okay. Somebody else asked a question. about so the clarification on some of the open source stuff. There's a question about Mapbox in relation to the OSGeo stuff. Is there any connection between those two organizations?
No, there's no official connection. We see ourselves as very, very much grounded in the open source space. You'll see that we're using a lot, very generally speaking, like in the geospace, you'll see us using like a lot of using either directly using a lot of very established open source. The geospace in general is that the open source toolchain is becoming more and more solid, and like the flexibility and like the level of control that it offers becomes a lot more critical and interesting for for the whole bandwidth of like geo users out there. I mean, starting with like the casual individual that creates a map for their web application, all the way to like the heavy GIS users. I think we'll see a lot more open source penetrating that space, and I think that's going to happen pretty fast over the next couple of years.
Okay. Well, you know what? There was one more question here, and then I'll let you go because we need to get on to the next speaker.
Okay.
The question is, what do you think are the top tile map design considerations?
This is a good question. I think design really, well, in general, design really matters. It's worthwhile to go to the exercycle to just make sure the map really looks good. It's just the first sort of the first rule if you'd like to effectively communicate something. In terms of general rules, I think one thing that we've really learned over here is keep it simple. There's way too many maps out there that have way too much information out there on it, and the density of information does not always increase the point or improve the point that you try to get across. So in short, keep it simple.
Okay, well, thank you very much. I just want to make a note to all of you, and Alex, you can comment about this if you'd like, that there are that Mapbox has some free accounts that you can get in and get started and do stuff. If you happen to have an organization that has needs robust map support and those kinds of things, there are some accounts that you can pay for, and you can go onto the website and look at that information. So if you do happen to have one of those, something bigger than just yourself trying to do a few projects, and you want to get out there and really kind of hit a big organization and do lots of bandwidth, lots of maps, there are some options for that. So, well, thank you, Alex. We do appreciate it, and we look forward to seeing you at the conference. And I hope that any of you who are interested in what he's talked about today, the Mapbox information, will get out there and go to their website and take a look at it. So with that, I'm going to switch the presenter over to Landon. Landon, are you there? Oops, just a second. I got you muted. Landon, are you there?
Yeah, can you hear me all right?
Yes, I can hear you.
Good deal.
Let me see if we can get your screen up. Somebody, while he's looking to get his screen up, I'll just, somebody commented and thanked Alex for participating there. Okay, there we see, by the way, if any of you see Matt Mitchell on the bottom of my screen, that's because I'm using Matt Mitchell's account to do this webinar. So, all right, Landon, what we're going to do is I'm going to, Landon doesn't have a webcam up. He's got his voice and he's got his screen. So we'll let you, I'll turn off my camera so that you don't have to stare at my face while Landon's talking, because I wouldn't want anybody to mistake the two of us. And Landon, I'll turn it over to you.
Thanks, Jeff. I appreciate it. So I'm going to talk a little bit today about the business case for greater land surveyor involvement in GIS. And this material is actually primarily developed for a land surveying audience, and it's typically a 2 to 4 hour workshop. So this is we're kind of squeezing this down into 30 minutes. So I've changed the content of the talk a little bit, and I still think a lot of what we're going to talk about today about changes in technology and the impacts on any kinds of professionals that work with spatial data is still relevant to the larger audience. So hopefully there'll be some things in here that GIS professionals can benefit from as well as those that come from a land surveying background. So just to give you a real quick snapshot of my background with GIS, I'm a land surveyor, went to a land surveying program at a college in Montana, and that was where I got my first exposure to GIS. The land surveying program there, we took a set of GIS classes in conjunction with the forestry department, and that's really where I got my first exposure to GIS. Then I started poking around a little bit with an open source desktop GIS that at the time was being funded by the government of British Columbia, a little desktop program called OpenJump, and that's really how my journey into GIS started. And over the last 12 or 13 years, as I've gotten more experience in the land surveying profession, I've realized that GIS is going to be a more and more important tool for land surveyors. And so I want to talk a little bit about the technology that's driving, it's really the main driver behind some important shifts in the land surveying profession, and the changes that are occurring because of technology are making it even more important for land surveyors to understand GIS, be aware of how it works, and be able to take advantage of it in their own practice. And so just to kind of give you an overview of what we're going to talk about today, we're going to talk about some of these technologies that have come onto the scene in the last 5, 10, 15, 20 years, and we'll talk briefly about their impacts. We're going to talk a little bit also about where some of those technologies might be headed in the next 5 or 10 years, and what changes those are going to have on geospatial professionals, not just surveyors, but GIS professionals and all kinds of other parts of our economy. So we'll spend some time on that. So we're going to talk about those specific technologies. Then we're going to kind of take a step back and just from a broader perspective, or from a wider perspective, talk about what are the impacts of those technologies as a group. How are they changing what land surveyors and what other geospatial professionals are doing? Then we're going to talk about what's happening with spatial data and this transformation, even in the last 10 or 20 years, of spatial data from a very specialized and high value product to what we would think of as more of a commodity, something that's relatively inexpensive, relatively abundant, readily available. And we'll talk a little bit about what are the impacts on land surveying and GIS when we see this transition of spatial data becoming a commodity. When that transition is completed here in the next few years, what are the impacts of that transition going to be? Because I think those impacts will be important. And then we're going to conclude with 2 slides. The first of those 2 is going to talk about some of the business reasons why land surveyors need to be more involved in GIS. And then we'll talk a little bit about some other non-business reasons why I think it's important for surveyors to be involved in GIS. And those are reasons, the reasons we talked about on that last slide, have more to do with the benefits that come to our economy as a whole and to our society when land surveyors get more involved in GIS. And I'll just mention here at the end of this slide, before we go into the rest of the presentation, that there are a number of land surveyors that are interested in GIS, that are starting to practice GIS, and that are concerned about the intersection between GIS and land surveying. And as an example of that, one of the groups I work with, volunteer groups I work with, is the California Geodetic Control Working Group. And that's a group of land surveyors and GIS professionals that are thinking about the future of geodetic control in California, how we fund that geodetic control network, how we maintain it, how we start to improve the other data sets in California that are layered on top of that control network, or that can be layered on top of that control network. So I think there's a lot of activity, a lot of land surveyors interested in GIS, a lot of activity in that area, and the California Geodetic Control Working Group is one example of that. And certainly, if you have any questions about that group and what it's working on, I'm more than welcome to take those questions either by email or by phone. And I was hastily putting together these slides, and I didn't have a chance to get my contact information on there, but I work for a little engineering and surveying company in Modesto, California called Odell Engineering. And so if you get a hold of Odell Engineering, then you'll have a way to get a hold of me. You can call the office here and get my phone number or my email. So that's kind of an overview of what we're going to talk about today. And so we're going to zip through this because I know we're a little crunched on time. It looks like we've got about 10 minutes left. But I wanted to talk for a couple minutes about some of the technologies that are really starting to change the way land surveyors practice their profession. And so that would include technologies like LiDAR. Of course, satellite positioning has had a huge impact on the way surveyors practice in the last 20 to 30 years, starting with GPS. Now we have Galileo, GLONASS, Compass, other satellite systems that are being maintained by other nations. You've got private companies like John Deere that are starting to offer their own GNSS kind of augmentation or improvement systems. You've got things like WAS, Wide Area Augmentation System. And then even when you think about GIS, the capabilities of your typical survey grade GPS instrument, just the capabilities in those instruments in the last 5 years are really incredible. The improvements we've seen there in the ease of use, the ability to perform under poor GPS conditions. And so GPS and other satellite positioning technologies are probably the #1 technology that has really revolutionized the way that land surveyors are practicing their profession currently. And we have some interesting changes in terrestrial positioning too, or ground-based positioning in the last 10 years. We've seen things like reflectorless distance meters, robotic total stations, and terrestrial or ground-based laser scanning or LiDAR has become commonplace, and that's just since I've graduated college, so that's in the last 10 to 15 years. Though all of those technologies have brought really incredible changes to the way land surveyors practice. Of course, we have satellite imaging and remote sensing. We haven't felt the full impact of it here in the United States yet, but we've got the drone-based platforms for imaging and remote sensing. I would say in the next 5 to 10 years, of all the technologies listed here, that will probably be the technology that has the most impact for both surveyors and GIS professionals. I think we're going to see drones really revolutionize a lot of the way that we do our work. We've seen open source software really become mainstream in the last 10 to 15 years. The talk we just heard about Mapbox is just one example of that. We're starting to see very small and affordable chip design, computer chips that include onboard positioning based on satellite positioning or other technologies. We're starting to see really a revolution in mobile computing. You know, most people now with a smartphone carry more computer on their hip than a lot of large institutions had at their disposal 20 years ago, and that's really quite impressive. And I know that in my own practice as a land surveyor, we've used mobile technology such as Android tablets to implement mobile data collection systems for GIS at a very low cost, and something that most users today, most employees at most organizations are comfortable now with the smartphone or tablet platform. So you can put a tablet into their hand, and with a mobile data collection application, and those users can go right to work. So I think, of course, we're only going to see the capabilities of mobile devices, including the location capabilities, is only going to get better as we move forward. So those are some of the technologies that are starting to have some serious changes on land surveyors and the way they practice their profession. I'm sure there's others that aren't on this list, but that's an impressive list. just the 6 or 7 items that are listed there. So what are the impacts of all these different technologies? Well, I've got a set of them listed here, and we can talk about a few of them. One is land surveyors and other professionals now have the ability to acquire geospatial data much faster than they could previously. So, you know, in the old days, you might have a 2 or 3 or 4-man survey crew might labor for several weeks to collect the same data that we can obtain now in a matter of hours or days. So that's been a major change that this technology has brought. We're starting to see better data coverage, so we're able to access spatial data like LiDAR or satellite imagery or aerial imagery for larger portions of the Earth's surface. The quality of that data is improving. The resolution, the accuracy, the precision of that data is improving. The data that we're collecting is more complete, more reliable. The data is becoming much more abundant. I would say that the growth in geospatial data is exponential. The amount of data that we're seeing collected every year is growing by leaps and bounds. And even the data collected by a company like my own, a local or regional GIS or surveying company, even that, the data that those individual companies are collecting is starting to grow by leaps and bounds. And it's not uncommon to have a company like mine that is producing gigabytes or even terabytes of spatial data for our projects on a weekly or monthly basis. That's not uncommon at all. So data is becoming more abundant. Obviously, data is becoming a lot cheaper to acquire as these technologies improve. And the final one listed there is we have the ability to collect data in ways and in places that we never could before. So we're just collecting data that it wasn't possible to collect not too long ago. And so I can think of 2 quick examples of that. One is the LiDAR capabilities they have now. They have LiDAR that can actually collect the bottom of shallow water bodies. So they use that for example, for coastal mapping, and they get topography data both above the water surface and to some depth below the water surface. And that area of shallow water, obviously in a coastal environment, is certainly a challenge to survey with traditional methods. So the capabilities of that LiDAR data are allowing us to collect data where it was really, we either couldn't do it before because of safety or logistical reasons, or it was just too expensive. A second example is terrestrial laser scanning, which allows surveyors to collect millions or hundreds of millions of points in the built environment, in the urban environment. Again, something that we just didn't have the ability to do before. It wasn't even possible. So those are some of the important impacts that these new technologies are creating for land surveyors and for other GIS professionals. And so what are the results of that? And I've got some issues with my slides here. I had to jump from a desktop to a laptop, so some of that got messed up. But I put together 2 or 3 quick graphs just to help us understand what the impacts are. The first graph here, we've got the cost of geospatial data on the left side increases from the bottom of the graph to the top, and then the improvement in technology on the bottom of the graph that improves from the left side of the graph to the right side. And so we can see as technology improves, the cost of geospatial data is coming down. And I would say that the shape of that drop in cost is probably not a straight line, it's probably exponential. So as we see small improvements in technology, we're seeing dramatic reductions in the cost of what it takes to acquire geospatial data. So that's an important change. This next graph shows that obviously as technology improves and we can collect more data, different types of data, more complete data, that just the complexity of the geospatial data that an organization like my own, like Odell Engineering, is collecting and managing, or the complexity of a data that a small city or a utility company might collect and manage. That complexity is also going up as technology improves and we start to collect more data. So that presents some unique challenges for organizations that have been the traditional stewards of spatial data of one kind or another. And this last slide is also an important slide. This graph shows that as technology improves, we find that the cost and the feasibility of GIS projects, the cost of implementing a GIS project goes down and the feasibility of implementing a project goes up. And so what we're finding, and we will continue to find as these improvements in technology drive these changes, is it's going to be easier and easier to implement GIS systems. And the return on the investment is going to go up because the cost of the data that we need, and not just the data, but the software and the hardware that we need to implement an effective GIS is going to go down. And so one of the takeaways from that, I think, for land surveyors is there is going to be more and more work helping organizations to not only organize and manage their spatial data, but to extract value from it. So what are the impacts of the technologies that we've just talked about? Well, I think there's important impacts that land surveyors especially want to be aware of. And one is that we're taking less and less skill to acquire spatial data. So even 20 or 30 years ago, it required some pretty hardcore math skills, some dedicated knowledge of equipment and hardware to be able to produce basic spatial data. And I think what we're seeing is that specialized knowledge is no longer required in many instances to get basic position information. And the classic example of that is, the soccer mom on her smartphone. And she doesn't have to know anything about trigonometry or datums or geodesy to be able to navigate from her home to the local department store or the pharmacy. And so certainly less skills being required, less labor is required. We talked a little bit about that. We have the ability now to collect a lot more data with fewer people. And so the result of this is a lot of land surveying companies like my own are beginning to see that the profit margins on our traditional data model or business model, which has been to produce spatial data, those profit margins are getting tighter and tighter. And I think most land surveyors will find that those profit margins are going to continue to be squeezed as we move into the future. And I'll give you one quick example for that because I know it's almost lunch. As we've seen the advent of LiDAR, there's less and less demand for traditional topo data from land surveyors because a lot of engineers and other professionals can use LiDAR data. And so that's an example of how the improvements in technology is beginning to tighten the profit margins on the work that surveyors have traditionally had producing spatial data. So what are the business lessons for land surveyors? What are the business reasons if you're a land surveyor to get more involved in GIS? And so I've got 4 here. We'll zip through them. The first is it's going to be more difficult to stay in business as a kind of a traditional spatial data provider. So, if your primary source of income is producing topo data, you're probably in trouble here in the next 10 years. I think we're going to see these new technologies encroach more and more on your revenue streams, and there's going to be more and more surveyors competing for less and less of that work. And so that's going to push prices down. It's going to push profits down. I think we're going to find organizations, and not just surveying organizations, but any type of agency organization that has to manage spatial data, so local governments, state governments, the federal government, utility companies, large landholders, those organizations are going to struggle to manage this massive amount of data that is headed their way. And you can think, for example, of what's going to happen when drones become mainstream, and any reasonable sized organization can send out a drone to collect LiDAR or traditional color aerial photography or infrared photography, and just the massive amount of data that's going to be headed at those organizations. How do they organize that? How do they store it? How do they access it? How do they catalog it? So they're going to struggle with that. Organizations are going to struggle to extract value from all this data. And I think remotely sensed data is a perfect case study in that. We're starting to see massive amounts of remotely sensed data like LiDAR and aerial photography, but that doesn't mean it's always easy to get value out of that data. So how do organizations cheaply and efficiently extract value from that data? What part of that data extraction process do humans have to be involved in? What part can be done by machines? I think organizations are going to struggle with those questions. And as we mentioned on the previous slide, I think we're going to find that GIS projects, quote unquote, or applications of spatial data are going to become more affordable and more effective. And so what I like to tell land surveyors is they need to make this transition from consultants or advisors that produce spatial data to the type of consultant that helps organizations manage and extract value from the spatial data that they're already going to have access to. And that's a challenge. I don't want to underestimate the difficulty of that transition, but it's an important transition for our profession to make, I believe. So now I want to talk about, this will be our last slide, and then I'll take questions for a couple minutes if we have time. What are some of the non-business reasons for land surveyors to be involved in GIS? You know, why would society as a whole and our economy benefit from greater land survey involvement in GIS? And I think there's several reasons. One is land surveyors, because of their historical role in society, have a very unique understanding of a lot of the things that make effective use of spatial data possible. That includes understanding of map projections, datums, coordinate reference systems. We understand, probably like no other profession, measurement and measurement error. We understand when accurate measurements might be required and how to obtain that accuracy. I think we have really a unique understanding of the collection of spatial data, especially in the field. I think land surveyors have been doing that for hundreds of years, and it's certainly played a unique role in the United States in collecting information about the land that we've used now for 200 years. And so I think that experience is certainly something that our society from a whole can benefit from as we move into this new world. And then finally, I think land surveyors, because of their historic role, have a unique understanding of our land systems, the way land is described and sold and used and developed, and also the way our infrastructure systems operate, our transportation systems, communication systems, utility systems. And I think as we move into this world where more and more organizations are using GIS, that knowledge will be of value.
Hey,
so that's
Landon?
the end of my presentation. Yep.
There's a question here. I thought it might be at that point, it might have been a good place to jump in with this one.
No. Good break.
It says, the Professional Land Surveyors Act here in California says that a licensed surveyor should be determining the position of fixed objects on the surface of the earth, and a bunch of other items that define what locating something is. Do you see a change in the Public Land Surveyors Act coming in the future?
That's a good question. I think the reality is the current law as it is set up is probably already out of date given the technology that we have. And I think land surveyors guard that ability to locate objects pretty jealously. I think we're going to have to come to grips with reality and recognize that there's going to be other professionals that locate features. I think the key is, the best solution in my mind, is modifications to the law so that land surveyors are still involved and responsible for location of features on the Earth's surface where public health and safety is involved. So we're talking about critical infrastructure, land boundaries, and I think we need to recognize as land surveyors that if a non-surveyor wants to go out and collect data about the location of agricultural crops or count the number of semis on an interstate, that's public health and safety is probably not involved there, and everybody will benefit economically if we allow other professionals to do that work. So that's an excellent question, and I think it's going to be a challenge moving forward.
One of the things I wanted to mention here, we did have a message from Scott Martin. Said he liked the fact that you fit the GCWG comment into your discussion. I know that at CalGIS this year, there's a couple people doing a presentation called Using and Supporting the California Geodetic Control Network. And so what I'd really like to encourage is any of you out there who are interested in this area to come to the conference and participate. I think there's plenty of room for discussion about this particular issue, and we might even have some time in some of our town hall sessions or such to discuss it. I don't have any more questions lined up right here. Oops. Oh, I guess that's the GCWG team that's going to be doing that presentation. So, Landon, I do appreciate it. I know for quite a while I worked as the GIS lead for Kern County, and I was in the surveying and engineering department and worked quite closely with the surveyors there. And there was always this discussion going back and forth about where it was, and at the time it was kind of like where GIS ended and where surveying began. But I think your presentation suggests that there's a lot more opportunity for us to work together and probably benefit to both professions.
Yeah, I appreciate you having me today, Jeff, very much.
Well, and it was good to meet you when we were up at a meeting up at UC Davis not long ago about for open source GIS. And so for those of you who are interested in participating at CalGIS and the conference, there's going to be a number of presentations dealing with various aspects of open source tools. And so I'd really encourage you to be participating in that. And Landon, would you like to mention a little bit where that group is, where people can find out more information about that open source group that you work with?
Yeah, California OSGeo. If you just Google that search term, you'll hit our wiki page, California OSGeo, or you could contact me here at Odell Engineering. And we typically meet at least once a year. We put on an event, and it's a very supportive group. So if you're kind of a traditional ESRI user and you're interested in dipping your toes into the open source world, there's a great mailing list there. People answer questions. So yeah, I definitely encourage folks to check that out if they're interested.
Okay, well, thank you so much for participating. For those of you who are remaining on now, we're starting to drop off now that you're done with your presentation. But I'd like to remind everybody that the conference is less than 3 months away, so get out there and register for the conference, get your hotel rooms going, and we really look forward to seeing you. The sooner you register, the better chance we have of having great food ready for you when you get there. So thank you so much. We appreciate it, and I'll sign off with that. Thank you.